Tree band was pretty good.
Well, yeah, because we had a professional drummer. That's all right.
Oh, yeah.
That always makes it easier. All right, so what did I just say? 8.7, solving trigonometric equations. Okay, let's start off really easy. Now, we're good. You got 8.7. Tonight's problems are going to be kind of pretty on the easy side, and then 8.8, then the equations get harder to solve. You're going to have to use identities to solve them. So tonight's one is just basic easiness. Okay, let me give you an easy one. 2 sine theta plus 1 equals 0. Yeah, make it even easier. Minus 1 equals 0. How would you solve this equation? Well, what you need to do is you need to isolate the trigonometric function. So since I see sine here, I want to isolate it. So add 1 to both sides. Divide both sides by 2. Everybody can do this part at least, right? Isolate the variable. Okay, now, is this a number I'm supposed to know for sine? See, so here, if you don't know your unit circle, you're going to struggle. So so even if you still don't know your unit circle, hopefully after you do this homework, then you will know it. Also, then doing this homework is going to help me for the test then. Yes, Noah. Huh? Wait, okay. So now you got to think. Sine of what angle will give me 1/2? So what you should be thinking in your head, well, hopefully you think about it in your head, but if you know when you start doing your homework, you might want to have your unit circle next to you, but then it's going to be so easy, and then what happens when you have a quiz or test and you don't have the unit circle? That's why you got to visualize or draw a picture. So where on this unit circle is the sine value, which is the y coordinate, equal to 1/2? Think about it. Where is the y coordinate 1/2? No, it should be there. Because remember, when you draw the triangle, you got the long leg, which is √3/2, and the short leg, which is 1/2, right? So what angle is that? 30 degrees. Okay, now, in the directions, you got to look at the directions. If it says solve for x in radians, then you got to give your answer in radians. If it says in degrees, then you got to give your answer in degrees, okay? So let's do both. So what is this? Pi/6 or 30 degrees. Let's do degrees first. 30 degrees. And then, is that the only one? No, wouldn't there be one on this side too? Because sine is positive in the first and the second quadrant, right? So shouldn't there be 2 answers? So right here, look, the y coordinate there is also 1/2. What angle is that? That's 150 degrees. Now, if you did it in radians, it would be, what's that one? Pi/6 and 5 pi/6. But are those the only answers? No. There's an infinite number of answers because you got to remember, once you have 30 degrees here, what if I add 360 to that? In other words, go once around the circle. That would be 390 degrees. Isn't the sine of 390 degrees also 1/2?
Yeah.
What if I added another 360? And another, and another, and another, and another. What if I subtracted 360? So 30 degrees. What if you subtract 360? You get negative 330. What if I subtracted another 360? And you can keep on going. So there's an infinite number of answers. So how do you write that? So this is what you do. You write the 2 that you know, right, that are between 0 and 360, and then you do this here. Then you put plus 360 degrees K, plus 360 degrees K, where K is an element of the integers. What?
Yeah, what?
Because think about it, if K is an integer, what are the integers? Okay, let's pretend we don't know anything. What is the set of integers? Dot, 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 -2, -1, 0, 1, 2, dot, dot, dot. These are the integers, right? What if I plug in 0 for K here? Plug in 0. Then you just get 30, right? 30 plus 0. What if I plug in 1 for K? Then you get 30 plus 360. What if I plug in 2 for K? You get 30 plus 720. You see how this works? So once you figure out 30, you can add 360, you can add another 360, And then when you plug in the negative numbers, then it's like you're subtracting, right? So this is how you write all the answers, because there's an infinite number of them. So once you figure out the answers that you know that are between 0 and 360, you simply add plus 360k at the end. That means multiples of 360 degrees. You guys get it? Multiples of 360. Oh, so same thing with the radians, Monsieur Park. You just go, so you get the two answers that you know, and then you go plus, so using the same reasoning, what do I write? What's the radian measurement of 360 degrees? 2 pi k plus 2 pi k, where k is an element of the integers. Everybody knows capital Z is the integers, right? Well, now we know. Now, what would happen if you didn't say k is an element of the integers? Then your answer would be wrong. You know why? Because what if you plugged in like 1/2 for k? 30 degrees plus 180 degrees, that would be 210. The y coordinate there is not positive half, so that's why you have to say k is an integer. So when you write all the solutions for a trig equation, we call this the general solution. So you got to read the directions in the book tonight. If it says write the general solution, then after you get your two answers, or whatever, how many answers there are, because sometimes there's 3, then you put the plus 360k or the 2 pi k after it. Easy, it's just mechanical. However, when I give my quiz and test, I'm not going to ask, maybe one problem I might ask for the general solution, because almost all the problems I'm going to give you are going to be like this. It's going to say, solve for theta, and then I'm going to say 0 is less than the theta related to 2 pi, like that. So I'm just going to ask you to find all the answers just from 0 to 2 pi. So in other words, you don't have to give me the general solution. So if these were the directions, what would the answer be then?
Just 38 degrees.
No, lose breath. Theta equal pi over 6 and 5 pi over 6. How come you gave radians, Mr. Park? Because it says to give radians. Look, 0 to 2 pi. What if my directions were solve for theta 0 degrees is less than or equal to theta is less than or equal to 360 degrees? What if that's the directions? Then what would your answer be?
30 degrees.
Theta equals 30 degrees and 150 degrees. Now, I haven't taught trigonometry for a really long time. But after teaching calculus, you know, the basis of learning all of this pre-calculus math is so that you can do calculus, right? Because when you take the AP exam in calculus, they never make you give the set general solution. It's always going to be between 0 and 2 pi. In fact, sometimes they make it only between 0 and pi. But the main thing is, because once you can do it between 0 and 2 pi, anybody can write this thing at the end, right? You know what I'm talking about? Because trig functions just repeat themselves, right? Okay, so this is an example of an easy equation. But you know what? I would guess most of the time you should do radians, because that's what we do in calculus. Everything is radians in calculus. We don't do degrees. Degrees is just an artificial measurement. The only reason why we have degrees is because of the Mayans, right? Who are the Mayans? Okay, are we ready to kick it up a notch? Too bad we are. 2 cosine squared theta. No, I changed my mind. 4 cosine squared theta equal 3. Okay, now these are the directions. So now you only have to give me the answers that are between 0 and 2 pi on your unit circle right there. Okay, so we need to isolate the variable. How do I isolate the variable cosine theta? Divide both sides by, it rhymes with more. 4. And then how do I get rid of this square? You square root both sides. Okay, now, here. You know what? I just want to see how much you know. If you have x squared is equal to 4, what happens when you square root both sides? I just want to see how your algebra background. If I square root both sides, what do you get? X equals plus or minus 2, correct? Why? See, teachers always write this down. Teachers always do this, but you know what? I mean, it's correct, but they're missing the middle step, so that's why students, they get confused. They think the square root of x squared is x, and the square root of 4 is plus or minus 2, but that's two mistakes right there. That's two mistakes. What is the square root of x squared? It's not x. It's not x. It's, okay, I'll tell you what. If you took out your Algebra 1 or Algebra 2 book, this is always printed in it. The square root of x squared is the absolute value of x. Does that look familiar enough? Oh gosh. And what's the square root of 4? It's just 2. It's 2. It's not plus or minus 2, it's 2. But see, a lot of teachers, like I said, they go from here to here, and that's why students, they think that's x and that's plus or minus 2, but that's two mistakes right there. Okay, so the absolute value of what number will give you 2? Plus or minus 2, right? So this plus or minus is coming from this absolute value. Okay? So this is correct mathematics right here. Do not think that the square root of 4 is plus or minus 2. You're going to be laughed out of the dormitories if you go to college. So if I square root both sides, see, most teachers leave out the middle step. They go, oh, cosine theta equals plus or minus, what's the square root of 3/4? What's the square root of 3? What's the square root of 4? 2. And that plus or minus is there because what? Of the absolute value. See, you guys are learning something. Now, is this a number I'm supposed to know for cosine? Yeah, if you come out with a number that you're not supposed to know, like here, what if I came out to cosine theta is 1/3 or something? Is that a number I'm supposed to know for cosine? No. So then, how do you do it? You use your calculator, but I'll teach you how to do that next time, okay? So tonight's homework, it's all going to be like numbers you're supposed to know, like √3/2, √2/2, 1/2, 0, or 1, right? Okay, so now you just got to know your unit circle. Cosine of what angle is plus or minus √3/2? Now, think of your unit circle.
30.
Cosine of what angle is either positive or negative √3/2? Where would that be? Wouldn't that be like here, 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 and here?
30.
Like here? We call that the pi/6 family. Like that. Okay? So what would that be? 5/6. What's this one?
5/6.
Oh, you guys think you're good, huh? What about that one? 7 pi/6. And then what about that one? 11 pi/6. And do I need to write the plus 2 pi k? No, because only between 0 and 2 pi. What if they didn't have this? Then you better write plus 2 pi k. Yeah? Oh, so this is not that hard, it's the part. No, it's not. You just gotta know your unit circle. In fact, you know the kinds of drills that we used to do? I remember when I was in high school. My teacher used to shout out an equation like this. Tangent theta equal 1. And then you just put your arms where it is on the unit circle like this. So the whole class had to do that. Right? Because think about it. On your unit circle, where is tangent equal to 1? There and there, right? So you just put your arms where it is. Oh, for real, it works, you know. Okay, let's try another one. Cosine theta equal -1/2. Right? Where on the unit circle is cosine theta -1/2? Wouldn't it be there and there? Where is the x coordinate -1/2?
Okay.
Okay, let's do it now. Let's do a sine. Sine theta equal -√2/2. See? Now you got it. So then, after a while, since a lot of my nephews and nieces, they all like, you know, they're in high school and stuff, so at Thanksgiving I used to play this game with them. No, so I would yell out a trig equation and then they all have to stand there and put their arms where they're. But you know what? It helped them.
That sounds like a funny thing to record.
Okay, let's do a couple more and we're done. Okay, so let's do a tangent then. I need green chalk. Tangent. So you can see right here, if you don't know your trig values, what's going to happen now?
You're gonna
Pain. Ping! That's what's gonna happen. So let's just watching that. Rocky 3. You guys watch Rocky 3?
Yeah, AMC.
Huh?
On AMC.
Oh yeah. Rocky 3, right? With Clubber Lang.
Yeah.
What's your prediction for the match, Clubber? Pain! I'm trying to think of root 3 tangent theta plus 1 equals 0. Solve this equation. Okay, you know what? Let's do degrees now. Let's get well-rounded. Solve for theta, but I want theta to be, you tell me, between 0 and 360 degrees. 2 more examples and we're done. Okay, so first step, isolate the variable. Can we do it all in one step or do I have to go step by step? Can everybody like do this in their head? What if I move the 1 on this side? It would be -1, right? And then divide by the radical 3. Can we do this? Is that a number I'm supposed to know for tangent? Yeah, it is. Okay, so now you just think. Tangent of what angle is -1 over root 3? Where's the arms? Did everybody get this? Okay, if you don't want to raise your arms, at least draw the unit circle. Okay, where is tangent -1 over root 3? Wouldn't it be there and there?
Tangent is negative in the second.
Yeah, so you know one answer is going to be in the second and one answer is going to be in the fourth, right? Okay, so what's that one?
150.
And we're doing degrees now. 150. And then what's this one? 330. Do I have to put the 300 plus 360K? No, very good. Okay, last example. Solve for theta, period. Okay, so let's do a secant, cosecant, or a cotangent. Somebody pick one. Secant. Okay, secant theta plus 2 equals 0. This is so easy. My dog can do this. Okay, subtract 2 from both sides. Secant theta is equal to -2. Now, is -2 a number I'm supposed to know for secant? Mr. Park, I only know sine, cosine, and tangent. I'm not good at secant, cosecant, and cotangent. Then change it. This means the same thing as cosine theta equals. What's the relationship between cosine and secant? They're reciprocals of each other. So if I reciprocatize both sides of the equation, cosine theta equal -½ So if you don't like secant, change it to cosine. See, like, what if you had cosecant? Cosecant theta equal 2 over root 3. What? I don't know, Mr. Park. Then reciprocatize both sides and you get sine theta equal root 3 over 2. Oh, now I get it. Or if you have cotangent theta equal radical 3, I don't know, cotangent, Mr. Park. Then reciprocatize both sides. Tangent theta equal 1 over root 3. So, Mr. Park, are you saying I gotta know sine, cosine, and tangent minimum then? Yes, because the others are just reciprocals. So if you don't like secant, change it to cosine. Now, do we know this? Cosine of what angle is -½ Okay, let's draw it. Where on the unit circle is the x value -½ Right? So what would that be? And we're doing degrees now. Oh, I didn't say here. I changed my mind. I want to do radians now. In radians. Okay, what's this one? People, unit circle. We're not moving until we get it. Okay, it's 120, but we're doing radians. Look, okay, you guys forgot the unit circle already. Look, the pi over 6 family is the one that's close to the x-axis, right? Pi over 6, 5 pi over 6, 7 pi over 6, 11 pi over 6. The pi over 3 family is the one that's close to the y-axis, right? Pi over 3, 2 pi over 3, 4 pi over 3, 5 pi over 3. And the pi over 4 family, here I'll draw a new one, is the one that's right in the middle, right? The pi over 4 family. Pi over 4, 3 pi over 4, 5 pi over 4, 7 pi over 4. So since this one is close to the y-axis, which family is this? The pi over 3 family, which is, okay, see now we got it. And then what's the other one? What's this one? Just take a guess. Okay, is that a guess? And then how come I left a space? Because it doesn't say to restrict the answers between anything, so I gotta give the general solution. So what do I write? Do I write plus 360k?
No.
Okay, very good. Yeah, you guys are learning. And then plus 2 pi k, box that, that's the answer.
No,
No.
don't forget the KEZ.
Okay, very good. K is an element of the integers.
What do you do to your Z's?
What? Come on. Look, what is the set of real numbers? That's the set of real numbers, right? We make a double bar, right? Does that even look familiar? No. Real number. You guys ever wonder why your teacher put the double bar?
I just accept it.
Then how come you don't accept it when I write the double bar on the Z then?
I don't know, I just.
Okay, got 10 minutes left. I want to correct those and get it back to you. Okay? So, if you need to make any last minute adjustments, you better come in Monday morning and talk to me. Hopefully you don't have to make adjustments, but do that speed quiz on your own now. No help. No identity sheet.